Hi, welcome to my channel, Joyman vs Code. I hope you enjoyed the previous video about debugging, how to debug in a scientific way. Today, again, we are going to talk about debugging. This time, we are going to talk about debugging others' problems. Today, we are going to talk about some tips before we debug others' problem. Let me introduce mind maps before we go further because the talk is based on a mind map. Here is a repository. You can see it is mindmaps.github.io. This is my repository of mind maps, mainly related to software and technology. We are all debuggers. When we start our career, we debug our own code. But when we go up in the ladder, say you become a team lead or tech lead, then you become an architect, you may need to debug somebody else's code. If you are starting as a support engineer, then you may be definitely debugging somebody else's code. You have to understand how that code works and you need to guess what can go wrong, things like that. So before we debug all those code which is not written by us, it is better to have some checklist that will help us to debug very easily. Without further ado, let me open the mind map which I will be explaining. This is the software related mind maps and debugging. As you are seeing in the URL, the mind map source is from the GitHub. So if you want, you can fork the repo and do the changes and give a pull request. I can accept that. Or you can create totally separately your own repo. This uses planned UML to render the mind maps. There is already a separate video done on how to set up the planned UML using Visual Studio Code. This is a mind map at high level before we debug others' problem. This is what I am following. It may not be exactly suiting to you or your scenarios, but this can be a good starting point so that you can note down what are the things to consider before we jump into somebody else's problem and get trouble solved at all. So this view is little difficult to understand. So I am zooming in that part. From the we'll start from the left side. The mind map starts with the problem, everything revolving around the problem. So if somebody comes to us saying that I have a problem, can you please help me? Let us start with the defect description. The person who is coming to us may have done some debugging by their ideas and they may have gone some route and the original description might have changed. In the sense, they may find out different things and they may think that that is a problem. So the first thing, ask the original defect description. What is your original issue? Then the current issue. Once they tell the description, they may get the solution. It happens many times. That is what we call rubber duck debugging. If you are following the jargons in the industry, you may have heard about this word rubber duck debugging. Rubber duck debugging is simple. Just ask that person to explain their problem. Normally, during the explanation of the problem, he may get that idea. Oh, yeah, this could have gone wrong. This is a successful method people are using for solving others' problem. Then we need to understand the priority. Is it a development time or it is in the production? So if it is in production, we may need to stop our current work and help them. If it is development, the priority will be comparatively less. We can tell them come back later or let me Google any excuse, right? So that we can complete our current task. Next question is any design is available. Before we start debugging, let us ask them, do you have any design, how the system works? Do you have any sequence diagram or any flow diagram, at least some design notes, how you are doing the application? If there is no design available, then we know things can go wrong. So obvious. One thing we can ask them to create a design. So when they create the design, they may understand that yeah, these are the expected design flows and they can correct it. Now we got an idea about the problem. Let us move to the next section. The next factor we need to consider is reproducing or not. That is what this branch shows. If the issue is reproducing, we should ask, is it consistently reproducing? If it is consistently reproducing, the next question is like, is it consistently reproducing in the dev environment? If they say yes, then we can ask for an sample application. We don't want to work on their application. Their application may have 1,000 different things which may be affecting the issue. Ask for a sample application. If the sample application is available, it will be easy to debug. Similarly, if there is no sample application but there is test case, then it will be easy to debug and fix. Test case is an easy way to isolate the issue without creating a separate sample application. This mind map is not talking about the lower level technical details about debugging. This is a high level idea about the questions we should ask to the developer or the person who is coming to us for debugging his problem. Coming back, if the issue is replacing sometimes, our next step should be to make it consistent. If we don't make it consistent, it will be difficult to debug and fix the issue. Sometimes it may happen only in production. They may say that, yeah, in development everything is working, QA everything is working, but when we put into higher environment, production is stop working. This can happen due to many reasons. The Active Directory, any infrastructure things will be different there. For example, in the development and QA, they may not be having any load balancer, but in production, they have a load balancer. Similarly, the Active Directory may be different. A lot of things can be different in the production environment. This is a normal scenario that issue is only replacing in production. Then we have again a set of questions. Is it the first deployment? Your application is going first time to the production and first deployment failed. If that is scenario, we should look at the environment. The environment may not be in pair with the development on QA environments. In the environment side, we can check the settings, we can check the permissions. Again, we may not be knowing what are the settings to be done, what are the permissions to be done. We should ask them what are the settings and permissions are expected before putting your application into the production. Sometimes it may happen after installing a new version. Then we should check the deployment. The deployment may be faulty, it may be missing some DLLs or some config files. Some config files might not be modified. Then another scenario is we can review the chain set. So what are the chain set included in the new version and look for any potential problems. Again, one idea is to create a sample application by imitating the production scenario. If you are in Azure, you can create a sample application and host behind the load balancer, then issue may reproduce. In Azure, it is easy to get a load balancer than in an on-premise system. Again, next step, if the issue is reproducing in production only, try to reproduce in the development environment. So we can look for what are the combinations in production which are causing the trouble. The same we can try in the production as well. Another important thing is the workaround. So when the issue is reproducing in production, before we have the real fix, the important thing is to have a workaround so that the production can continue working. So look for a workaround or a small hack, manual step to overcome the issue. When I say manual steps, sometimes we have seen like IAS get stuck. So manually we can restart the IAS. So those kind of hacks can be done to keep the production up and running. This is another branch where the issue is not at all reproducing. Then the step should be to reproduce the issue. That is the easiest way to debug the issue. So in order to reproduce, we can again create a sample application. The sample application is a good approach to isolate the other components in the system. So we can narrow down the issue to one particular point so that debugging will be more easier. The issue may be reproducing by using some timing. The issue may be based on the timing. For example, there are two people working and they're trying to save a screen and they are getting the issue. So these timing based issues are difficult to reproduce. So we need to ask them, is the issue happening because when there are multiple users or when the issue is happening on a particular time, say the issue start happening after 6 o'clock or 8 o'clock in the evening. That may be the time some other scheduled tasks start running. So the scheduled task and the user task may be conflicting. We need to ask all these questions. I didn't include all the scenarios related to timing, but it's a common sense. We can ask the question to the developer, what is in the system that can cause a timing issue. Sometimes the issue may be user specific, particular set of users or particular user is getting the issue. If the user is from the Active Directory, we can look for different attributes, and maybe because one attribute is missing, the issue is happening. For example, the application is looking for the country in the Active Directory for the user, but for a specific user, the country attribute is missing. So user-specific issues can be addressed by that approach. Again, I didn't include all the sub-questions of user-specific scenarios. That again a common sense. As a debugger, you should ask all that questions. What are the application depending on the user-specific details? Another scenario is the environment. It may be working in the developer environment, but not in the QA environment. This is similar to the production versus non-production. Environment specific details, we can ask them. For example, load balancer is there or not, or any application security gateways are used in this environment, which is not there in the development environment. All those questions can be asked here. Then the race conditions. As developer, we know what is race condition. If there are many processes racing for one resource, the race condition can occur. And this will never be happening in developer environment. It may happen in a QA or higher environments where there are many users. Next approach is a scientific approach. There's a separate video done for scientific approach. I have provided the link in the description. Scientific approach uses an hypothesis driven approach where we document what are the steps we have done during the debugging so that people can change. Also, we can continue proper debugging on the next day, or we can take breaks without breaking our debugging process. Now let us consider another scenario. It is not reproducing and we tried whatever we can to reproduce the issue, still issue is not reproducing. In such scenario, we can have another approaches, access to the servers. So if we have access to the servers or the access to the logs, we can do some analysis and find out what could be going wrong or what is going wrong. So one thing is the logs. The logs may be telling the steps to reproduce. By analyzing the logs, we can recreate the scenario. Another source is stack trace. Stack trace will be helping us to understand how the program executed or how it ended up in error. Stack trace means how the program is calling functions one by one. So function A calls function B calls function C calls function D, and function D failed. That scenario or that error can be seen in the stack trace. By evaluating the stack trace, we can try to create a sample application and make that same code sequence. Another is error codes. Sometimes when the application error out, it may give error codes along with the error detail. So error code can be directly Googled and find out what can be done to solve the issue. Another option is debugging tools. There are debugging tools available to almost all the technologies to debug the production process. For example, in Windows world, there is a program called WinDBG. You can attach the WinDBG into the process and find what is going on. We can put breakpoints, we can display the variable values. Almost anything can be done using WinDBG. It may not be feasible in production without having a maintenance window. We can look for a maintenance window to do the debugging or try to replicate the production environment somewhere, then attach the debugging tools. This is more technology intensive thing than simple debugging. We should be knowing how to work with the debugging tools. It is not easy as writing a JavaScript application or a .NET application. We have to know bits and bytes. Another scenario, error at the client application. Your client application may be an WPF application, a desktop application, or WinForms, or it may be a browser application. The browser application may have an issue where there's no issue in the server. The server may be working just fine. So at that time, we need to differentiate whether the issue is at the client side or at the server side. Hope you got some idea about the questions what we need to ask before we start debugging others problem. This is helping me at least to save my lot of time when people coming to me for debugging. Combining this technique with the scientific method what we have seen in the last video, we can save a lot of time in debugging. If you have any suggestions or questions about this mind map, you can please add into the comment box. Also feel free to give a pull request to modify this diagram. As you can see, this is the organization and the repo in the GitHub. There are many other mind maps. I will try to make one video for each of them. Thanks for watching. Bye. If you liked the video and would like to see more videos like this, please subscribe. Also click on the bell button for getting the notifications.